So now we're going to adventure off into the world of making video games. Not an easy task. There's a lot to learn. We're going to start at the basic foundation. The idea that every game takes advantage of something called a game loop. Basically, a loop is just something that repeats itself exactly the same way over and over and over again. In the world of gaming, that is the actions that need to occur in order to create an interactive simulation for us. Now, not all forms of loops are interactive. Of course, if you watch a movie is just a loop of individual pictures that are shown very, very rapidly to create an illusion of animation. Old school traditional animation techniques did something similar. They might draw something like, let's see over here, they might draw something like this. And what you see here is a sequence of individual pictures, each one called a frame, and they're numbered. That's how we know they're a sequence. Now, each one of these things will draw a slightly different picture than the previous one. You can see how they all relate back to the previous one. This guy is effectively a little animation of a guy kicking twice. Now, this animation itself is very short. It's only 7 frames, 0 through 6, and it will show in order. Now, there's certain techniques we can do to make this last longer, but we'll get into that later. Basically, what's going to happen is in traditional animation, we show one picture at a time in order, and we do it very, very quickly. And if we do it fast enough, it will actually trick our brain into thinking that it's actually animating. It creates an illusion within our brain. The speed at which this actually changes over is called a frame rate, the number of frames per second. Why? Because each picture is called one frame of animation. Video games work in the exact same way, except in our case, one frame is a complete drawing of the entire screen. And it can be made up of a lot of different components, things like characters and environments and scores and all these other different little pieces that create one big solid image that is our screenshot. And depending on the game, that can be very complex or it can be very simple. It might be something as simple as, say, tic-tac-toe, where you're just seeing like oops, let me just put my pen on here, and there we go. It might be something very simple like this. Right, there's a basic game board, and every time the player plays, maybe they choose a quadrant, and then the next one comes over here or whatnot. Now that's a very simple game. Or you might get something a little bit more complex, where you have, like, you know, your blocks. You have your different blocks. Maybe a question block in there, maybe a coin, and maybe a little plumber guy over here with some nice overalls, and then maybe over here you have a little cone-shaped guy. No names or anything like that. I'm sure we can all figure out what game this is. And we can see that these different images start to get more and more complex. And even this is considered very simplistic by today's standards, as the game that's being drawn here was created over 30 years ago now. So what we can see here is that we get a lot of variation out of the same concept. Now, in our games, we're going to use this game loop as well. And it's going to be comprised of 2 separate actions. And these 2 actions are going to repeat themselves over and over and over and over again until the game is done being played. And these 2 actions, let me just get off this here. These 2 actions are, first, one is called, oops, where is it? There we go. Update. And that's number 1. And then that flows into number 2, which is draw. When draw is done, comes all the way back up and comes back through. So we create this looping structure that goes over and over and over and over again. And this happens in typical games at around 60 times per second. Oops. So we say that it has a frame rate of 60 frames per second. Now, what happens in each of these little sequences, or these little commands? In update, this is the most important one. Update does all the work of our program. It's called update for a reason. It updates all the different components, elements, scores, everything like that in our game. So the first thing that it'll try to see whether the user has entered any more input. So maybe they're clicking a key on the keyboard, or pressing a button on a controller, or doing some type of gesture recognition in like Xbox Connect, that kind of stuff. That is all input that the game may or may not take care of. Once the input has been received, then that input is then processed. So for example, it might trigger like a jump, or it might trigger like a fireball coming out of a character's hands or something like that. Once that stuff has occurred, other facets start to get linked in. Things like physics, things like collision detection, things like artificial intelligence, things like triggering sound effects. These are all part of update. And once all of the game's update information has finished executing, it then proceeds into draw. And here's the kicker. Update updates all the game information. It updates all the data. Oops. Where did that go? Sorry. It updates all of the data of our game. Draw simply looks at that. Let me see if I can draw an eyeball here. It simply looks at the data and then translates that data into a nice image on our screen. Right? We got a little guy down here. It translates all that information from just numbers into a graphical thing. So it might place a character at a certain location. It might have that fireball moving at a certain direction. All this exists only because the data states how the current state of the game is. So the data can exist just fine if the draw never occurred, because all the draw does is look at the data. But the data doesn't need the draw at all. That's why you could have old school games like text adventures and whatnot still have a video game. The graphics are icing on the cake per se. So the drawing command does nothing except for illustrate what's been set up in the data. There should be no other logic really involved, with the exception of some small selection statements that say, in this case, draw the menu. In that case, draw the game. In this case, draw the pause screen. All these different little things that are set up in that case. Those are called game states. But that's a little bit later on from now. So we have this game loop. We have the idea of a frame rate. And our games usually target around 60. Some smaller games might target 30 frames per second. And this is pretty fast when you consider TV and movies run at 24 frames per second. Your average high-end video game PC can handle a lot more nowadays. If you're dealing with anything virtual reality like the Oculus Rift or the HTC Vive, they all run at a solid 90 frames per second. They have to avoid motion sickness, or at least try to avoid motion sickness as best they can. There's other things like 3D TVs that'll run at 120 frames per second, and it varies from product to product and software to software, but every type of software usually has a goal. Like I said, games usually aim at around 60 frames per second. The human eye can only see so much. Right now, clinically speaking, the accepted number is around 150 frames per second that the human eye can actually pick up and register. So your games that are juicing up at 300 frames per second and you're all proud of it, it really doesn't matter past 150. So if you're just putting more hardware in, you're kind of wasting your money a little bit. Anyway, so this is a game loop, and we're going to continue on this discussion and work our way towards creating our first game.